Namaste, welcome back to the Pragna channel. You are watching Machine Learning Basics Theory. In the previous video, we have learned about classification technique, and in today's video, we are going to learn about clustering technique. And classification technique was, is it supervised learning technique or unsupervised learning technique? Yes, it is supervised learning technique. Whereas clustering is an unsupervised learning technique used in machine learning to group a set of objects or data points into clusters where objects within the same cluster are more similar to each other than to those in other clusters. Unlike classification, where data is labeled, clustering is used when the data is unlabeled and the goal is to discover the inherent structure or patterns within the idea. So that's what clustering is. How does it work? The input data consists of multiple data points, each with a set of features. For example, in a customer data set, each data point might represent a customer with features like age, income, and spending habits. The algorithm uses a similarity or distance measure. Example, Euclidean distance, which we have used in, if you remember it, K nearest neighbors algorithm to determine how close or similar the data points are to each other. If you remember, KNN was a unsupervised machine learning algorithm. So that's where we use the clustering. And that's why you are seeing K means here partitions. This partitions the data into K clusters where each data point belongs to the cluster with the nearest main. And it builds a hierarchy of clusters by either merging smaller clusters into larger ones. This is called agglomerative, or splitting larger clusters into smaller ones, which is called divisive. And then there is something called density based spatial clustering of applications with noise. What does this mean? This groups data points that are closely packed together, marking points that are in low density regions as outliers. Okay. Now that's all about the clustering algorithms. We have seen only one clustering algorithm so far, which is the k-means. Remember it, right? Again, if I have to explain these algorithms, which is a popular algorithm that partitions the data set into k clusters, with each point belonging to the cluster with the closest main. And the hierarchical clustering creates a hierarchy of clusters by either merging smaller clusters into larger ones or splitting larger clusters into smaller ones. And DBSCAN, a density based algorithm that forms clusters based on areas of high density, identifying noise or outliers in low density regions. And another one is Gaussian mixture models. This is a probabilistic model that assumes data is generated from a mixture of several Gaussian distributions, each representing a cluster. Okay, so these are some of the clustering algorithms, where you will use the clustering technique. And then once you pick the algorithm, each data point is assigned to one of the clusters based on the algorithm's criteria. The output is a set of clusters where each cluster contains data points that are similar to each other. Now, if you look at our real examples, first one is customer segmentation. Let's assume there is a company, a retail company, which wants to segment its customer into different groups based on purchasing behavior to target marketing efforts more effectively. By the way, this is what we are going to use in our step-by-step explanation. The data might include customer attributes like age, income, purchase frequency, average transaction value, and product preferences. Now the company applies a clustering algorithm like k-means to group customers into clusters. For example, one cluster might represent high income customers who frequently purchase luxury items, while another cluster might represent budget conscious shoppers who look for discount, someone like me. And the outcome after applying this technique, the company can tailor its marketing strategies to each customer segment, improving customer engagement and sales. And another example is document clustering. Let's assume there is a news organization which wants to automatically group articles into topics such as politics, sports, technology, and entertainment. This algorithm analyzes the text content of the articles, extracting features like the word frequency and key phrases. And the article, once you apply the clustering, the articles are grouped into clusters based on their content. For instance, articles discussing elections, government policies, and political figures might be clustered together under the politics category. And once you apply this technique, the organization can organize and search articles more efficiently, helping readers find relevant content more easily. Or you might even tag these articles with the appropriate category. So people, if they want to filter on a particular topic, the tag, they can filter it. Then image segmentation. Let's assume there is a medical imaging application which needs to segment an MRI scan into different tissue types such as bone, muscle, and fat. The algorithm analyzes the pixel intensity and texture in the MRI scan. Pixels with similar intensities and textures are grouped into clusters, with each cluster representing a different tissue type. Okay, how can the uh, hospital use it? The segmented image helps doctors identify and analyze specific areas of interest, such as detecting tumors or other abnormalities. And then we have anomaly detection in network security. Let's assume there is a cyber security team which wants to detect unusual patterns in network traffic that might indicate a security breach or cyber attack. The data might include attributes like the number of packets sent, duration of connections, and the types of protocols used. This algorithm clusters the normal traffic patterns, identifying outliers that don't fit into any of the clusters as potential anomalies. And the outcome, the team can quickly identify and respond to potential security threats, improving the overall security of the network. And the last example we have is recommender systems. A streaming service like Netflix or Spotify wants to recommend content to users based on their viewing or listening habits. The algorithm uses features like genre preferences, past watch listen history, and user ratings. Users with similar preferences are grouped into clusters. For example, one cluster might include users who prefer action movies, while another cluster might include users who enjoy documentaries. And the outcome? The service can recommend content that is more likely to align with each user's preferences, enhancing the user experience. And those are only some of the examples. There might be so many that you might already be using them in your real life. And the advantages of clustering. Clustering can reveal hidden features, structures, and patterns in data that are not immediately apparent. And it's unsupervised learning. Clustering does not require labeled data, making it useful for exploratory data analysis when the categories are known. And versatility. Clustering can be applied to various types of data, including numerical, categorical, text, and image data. And what are the considerations when using clustering? Of course, just like in KNN, we learned choosing the appropriate K value is very important, correct? Some algorithms like K-means require specifying the number of clusters, which is K, in advance, which may require experimentation. And the resulting clusters may not always be easy to interpret, especially in high dimensional data. And some clustering algorithms are sensitive to outliers, which can distort the formation of clusters. So before going into summary, let's jump into our step-by-step explanation by picking a scenario. Imagine you work for a retail company that wants to understand its customers base better. The goal is to group customers into segments based on their purchasing behavior. So the company can tailor its marketing strategies to different types of customers. This process of grouping customers into segments is known as, you assumed it correct, customer segmentation. Okay. So how clustering can be used for customer segmentation? First of all, let's understand the problem. What is our objective? The objective is to segment customers into distinct groups based on their purchasing behavior, allowing the company to target each group with personalized marketing efforts. And what type of problem is this? This is an unsupervised learning problem because the company does not have predefined labels or categories for customers. Instead, the goal is to discover the natural groupings within the customer data. Okay. Unsupervised learning problem. I think by now you understood when to use supervised algorithms, when to use unsupervised. So as usual, the first step is prepare the data set. Correct? The company collects data on various customer attributes that might influence purchasing behavior. This might include, let's assume for the sake of discussion, we have customer 1 and let's say their age is 35, income let's say 70K, and then let's say their spending score is 60, and let's say their purchasing frequency is 5 per month. Yes, there are people who buy more than 5 per month, and the transaction value, let's say $200. Let's say you have another customer too, and their age is 50, and income is 90K, and spending score is 80, purchasing frequency is 8 per month, and again this is average transaction value, and let's say this one is $300. Okay, let's assume we have these two customers with us. Okay, now once you prepare the data set, what is the next step? Yes, you said it correct. Picking an algorithm. Correct? And in this case, what are you going to pick? It's up to you what you pick. The K-means, which is a popular choice for customer segmentation. It partitions the customers into K clusters where each customer belongs to the cluster with the nearest mean. It's also called centroid. And if you pick hierarchical clustering, which builds a hierarchy of clusters that can provide a more nuanced understanding of customer relationships. And DB scan, which is useful if you expect some customers to be outliers or if you want to identify dense clusters of customers. Okay, so for us, we are going to pick K-means here. And you might remember, whenever we have these different values, different numbers or different what do you call features, then what do? We do normalization, which is part of preparing the data set itself. Correct? So what do? Normalization. If it is text data, you tokenize it. If it is in numbers, then you normalize it. They will scale the features like income, spending score, so that they contribute equally to the distance calculations. This is important for algorithms like k-means that rely on distance measures. Now once you do that, you picked already algorithm. Now you will apply that algorithm. Suppose you choose k-means clustering and decide to segment the customers into 4 groups. So you will assign k as 4 if you want the customers to be in 4 groups. The algorithm starts by initializing 4 random centroids and then iteratively assigns each customer to the nearest centroid, updating the centroids based on the customers assigned to each cluster. Okay. After the algorithm converges, you will have 4 clusters of customers, each with a centroid representing the average customer in that particular cluster. I'm not explaining again this because we already covered the KNN, which is the first video. If you haven't seen that, go ahead and watch it. Okay, so example clusters will be, let's say, since we said 4 clusters, right? First cluster would be, it will group something like high income frequent shoppers. Okay, with high spending scores. Then cluster 2 will be something like younger customers with moderate income and high spending. Cluster 3 will be something like older customers with lower income and low spending scores. And cluster 4 will be like budget conscious customers with low spending scores but frequent purchases. Maybe I will be in that category. Okay, so there will be these kind of different groups that it might cluster. Okay, and if we have to understand these for the cluster 1, which is high value customers, okay, high income, frequent purchase, high spending. So what would be the marketing strategy for the company? It offers premium products, exclusive deals and loyalty programs. And for people like cluster 2, which are young spenders, the marketing strategy would be like promote trendy and value for money products, use social media marketing. And for senior budget shoppers, they focus on discounts, senior discounts and value bundles. And frequent bargain hunters like me, they will send frequent promotions, coupons, and discounts to encourage repeat purchases. This is how different companies implement their marketing strategies. And based on these, the company can now develop targeted marketing campaigns for each customer segment, increasing the likelihood of engagement and sales. For cluster one, the company might send personalized offers for luxury products and etc. Now there are, you can interpret these results as well, and something is called silhouette score. I don't know if I am saying it right. This measures how similar each customer is to their own cluster compared to other clusters. A higher silhouette score indicates better defined clusters. And then there is another thing called inertia within cluster sum of squares. This measures the compactness of the clusters, which means lower inertia indicates tighter clusters, meaning the customers within each cluster are more similar to each other. Okay. And the using the results for business strategy for product development, the insights from clustering can inform product development by identifying which types of products are most popular with each segment. And by understanding the characteristics of different customer segments, the company can develop strategies to retain high value customers and improve the satisfaction of lower spending customers. The company can use cluster information also to recommend products that are likely to appeal to each segment, driving cross-selling and upselling opportunities. And we already discussed the advantages and challenges, so let's jump into the summary. Clustering is a powerful unsupervised learning technique that groups data based on similarity. And this is widely used in customer segmentation, document organization, and etc. And this reveals the natural structure of data and aids decision making across industries. All right, so that's about this video. If you enjoyed this, don't forget to subscribe, like, and comment, and see you in the next video. Have a great day. Peace out. Love you all.